So in each case, find which one has more probability, positional probability in each case. 1 mole of H2 at STP or 1 mole of H2 at 100 degrees and 0.5 atmospheric pressure. I have here H2 at 0 degrees, while here is 100 degrees, so the temperature is higher. And here's the pressure is 1, but here the pressure is low, so the pressure becomes lower here. If the temperature is higher and the pressure is lower, the volume is bigger. So this one has bigger volume, so the probability will be bigger for this one. While if N2 and the other one is still N2, but here it's at STP, so the temperature is 0 degrees. Here it's 100 Kelvin, so the temperature is bigger. Temperature here is bigger than the temperature is here, and the pressure here is smaller. Oh, sorry, the temperature here is bigger because this is temperature here is bigger, but the pressure is smaller because pressure here is 1 and pressure here is 2, so pressure is smaller. In the first one, temperature is at STP is 0 degrees, but the 100 Kelvin. Bigger. This means that the volume of this one is bigger because the pressure is less, so the volume is bigger. So in this case, this is a more probability. 1 mole of H2O and 1 mole of H2O. This is 0 degrees and this is 20 degrees. This is liquid, this is solid, and this is liquid. Of course, the probability of liquid is more than the solid, so it has higher randomness and higher entropy and higher probability. Which of the following involve an increase in the entropy of the system? Melting of a solid, sublimation, freezing, mixing, separation, and boiling. Of the three phases, the solid, liquid, gas, solid is the most ordered. This has the smallest entropy of all of them, is the solid, and the liquid has higher entropy while the particles are more disarranged or more disordered, so the entropy for it will be higher, and the highest of them will be gases. So anything that causes a change from the solid to liquid, like melting, or from liquid to gas, like boiling, will cause, or from solid to gas, which is sublimation. This means A and B and F. So melting, sublimation, and boiling, they are all changing. The opposite of D, so melting and sublimation and boiling, and the opposite will cause the entropy to decrease. So freezing or separation. Let's look at freezing and separation. Substance goes from more ordered liquid to more ordered solid. This is freezing? No. What about mixing? Mixing was increased in disorder, becomes this instead of placed in one place, the particles, it becomes more disordered. While separation, what does separation causes? It decreases the positional probability, so it becomes less entropy. So I will choose melting, I will choose sublimation, I will choose mixing and boiling, A, B, G, and F. Now predict the sign of delta S of the surroundings for the following: H2O into H2O from liquid into gas. This is boiling. We just mentioned that boiling increases what? It is an endothermic process, and all endothermic processes decrease the entropy. Endothermic process decrease the entropy of the surroundings. Why? This is your system. You are losing heat from the you are losing heat from the surroundings and going to the system. It's endothermic process. So it decreases when the heat decreases, the entropy of the surroundings will be less. So the S will be negative. Okay, what about iodine into iodine from gas to solid? Iodine from gas to solid. This means that you are decreasing the temperature. It means it is an exothermic process. So this iodine exothermic process changes from your gas into your solid. So It needs what? It needs to make bonds, and making bonds is exothermic. This is exothermic process. It releases heat to the surroundings. So as the temperature of the surroundings increase, its entropy is going to increase also. Whenever you increase the temperature, the entropy increases, and whenever you decrease the temperature, the entropy decreases. Now calculate the delta S surroundings for the following reactions at 25 degrees and 1 atmospheric pressure. And delta S of the surroundings for A is equal to minus delta H over the temperature. What is the delta H? It's negative 2221, so we'll make it negative of the negative, so it will be a positive, and then dividing it by the temperature. What is the temperature? Temperature is 25, change it by addition of 273, it will be 298. And the second one also do the same, but this time it is positive, so it will be negative of the positive, so it will be a negative value, and divided by 298 again. Now don't forget that this result comes in kilojoules, and it has to be changed into joules, because in joules, this is the result for the entropy. Entropy result has to be in joules only. So I have to change from kilojoules into joules by multiplying by 1000. Now, given the values of delta H and delta S, which of the following changes will become spontaneous at constant temperature and pressure? So, the first one, delta H is positive and delta S is positive, and temperature is equal to 300. And delta G is equal to delta H minus T delta S. And when delta G is negative, the process will be spontaneous. If it's positive, then the opposite is spontaneous. So delta G is equal by calculation to 24,000. So it is positive, so it's non-spontaneous. Now take care, this one is delta H is positive and delta S is positive. So the result is going to be always positive. Let's see. Because this is positive and positive, there is only a chance for this to be negative if the temperature is very high. Like if you have something that will make the total of delta S multiplied by T is more than 25,000, then in this case only it will be negative. And this is what we have studied. We have studied that the only case in which you can make the delta H positive and delta S positive and the reaction becomes spontaneous is at very high temperature. In this case, it will be already delta G is negative, so it will be spontaneous. B is the one that we are speaking about here. It's 25,000 joules. This is the delta H. We change it minus. This time it is 300, but multiplied by 100. So 300 multiplied 100 is 30,000. When subtracted from 25, it is minus 5,000. The reaction here is spontaneous. It's still a positive and positive, but the entropy here is higher, so that's why it become a negative value at the end. Here delta H is negative and delta S is positive, and we said when the delta H is negative and delta S is positive, the result is going to be spontaneous at all temperature, if it's low or if it is high. If it is low or high, then you are always going to get a negative result. Negative 10 multiplied by 5 multiplied by the temperature is 298, so this is a positive result, so it will be much more or less compared to the delta H. Why? Because if delta S is positive, so the negative of it, so this is the delta S of positive, so the negative of it will be always negative, so we will be always getting a negative result, and delta H is already negative, so the result can never be positive. The last one is D, where there is a negative for the delta